Recall that from the previous lesson, the conditional probability formula was probability that A given B is equal to probability of A and B divided by probability of B. Now we can multiply both sides of this equation by probability of B to get this formula, probability of A and B equals probability of event B times probability of A given B. This is the multiplication rule. Now there are different ways of writing this. So for example, we could have written this multiplication rule like this. Probability of A and B is also going to be equal to probability of A times probability of B given A. So the important thing to notice here is that the event in here is going to be the same as the event that we know information about. So probability of B times the probability of A given B. And same thing is true here too. So probability of A times the probability of event B given A. Okay? Now, we have already learned about independent and dependent events, and the multiplication rule is again the rule to find the probability of combined events, so A and B, so probability when both A and B happen together, and then that's going to be probability of A times probability of B given A, or probability of B times probability of A given B, depending upon what information we have. Okay. If A and B are independent, so if A and B are independent, then it means that the probability of one event doesn't affect the other. So in that case, the probability of A given B is going to be the same as probability of A, or that probability of B given A is going to be the same as probability of B, because it doesn't matter what event A or what event B is, right? So probability of A given B means probability of event A given that event B has already occurred, but since A and B are independent, doesn't affect the probability of A. And likewise, the second line here, probability of B given A means probability of event B given that A has already happened, but if A and B are independent, it's just going to be the same as probability of B. Let's take a look at some examples. I think that will make this notion more clear. So for example, suppose that a die is rolled twice, and we want to find the probability that we roll a 2 in the first die, no S in there, and 5 on the second die, right? Let's calculate the individual probability. Probability of rolling a 2. We know it's 1/6, one outcome out of 6 possible outcomes. Likewise, probability of rolling a 5 is 1/6. So probability of rolling a 2 and 5. Now it's understood that you roll a 2 first and then the 5 second. Based on the multiplication rule, it's going to be probability of rolling a 2 times probability of rolling a 5 given you roll a 2 in the first roll. So let me write the formula here for easy reference. So probability of A and B equals probability of A times probability of B given A. So that's the formula, the multiplication rule that I'm using here. Now notice that getting a 2 in the first row doesn't affect what happens in the second row. So this probability of getting a 5 given a 2 is really the same as probability of getting a 5, because these two events are independent. So it's going to be 1/6 times 1/6, which of course equals 1/36. So when two events are independent, the multiplication rule always comes back to just multiplying the two individual probabilities, right? So for independent events, right, probability of A and B is always probability of A times probability of B, like we learned last week when we talked about independent and dependent events. More interesting would be the case when the events are not independent or when they're dependent. That one we'll take a look at in this next example. So say we have a bag that contains 4 red marbles and 6 green marbles. And we want to know the probability of picking 2 red marbles from the bag if the marbles are picked without the replacement. Now, this without replacement part makes the two events dependent, because what's going to happen in the second pick depends on what we picked on the first one. Okay, so let's write the information that we already know of. So probability of getting a red on first pick. Well, there are 4 red marbles out of 10 total, right? 4 red, 6 green, that's a 10, which we simplify as 2/5. So that's the probability that you pick red on the first pick. Now that's also going to be the same probability for the red to be picked on the second pick if we replace the marbles. So if we pick the red on the first one and we put it back into the bag, reshuffle it, and then if we picked again, right? But that's not going to be the same if we picked it without replacement. So if we pick the red first, we don't put it back, so it's going to affect the probability of getting a red on the second pick, right? So for that we need to use the conditional probability. So using the formula, so probability of getting a red on first and second pick is going to be equal to probability of getting a red on first pick, right, times, now we got to multiply this with the probability of picking a red on second pick, given that we got a red on the first pick. So that's where the conditional probability comes in when we have dependent events. Now, we already established that the probability of picking a red on the first pick is 2/5. Now, the probability of getting a red on the second pick, let's think about that. So we picked a red, so we didn't replace it, so we only have 3 reds left in the bag. So the probability is going to be 3 out of, and we only have 9 marbles left now. We already picked 1 red, so it's going to be 3 out of 9. 3 out of 9 can be simplified as 1/3, right? So the probability that you pick both marbles without replacement is just going to be 2 times 1, which is a 2, over 5 times 3 is a 15. Right, so this is the multiplication rule. We kind of already did problems similar to this last week when we talked about dependent and independent events. But here we are making it more formal, and we also have a formula. All right, so that's it for this lesson.